Hi students, now we are going to see the difference between moment of couple, moment of force, moment of inertia in our play with physics. Okay, using this object, we are going to explain all these three. First, let us hold the scale at the midpoint, at its midpoint. When I apply a force F here, now another force at this point acts, but acts in the direction opposite to the direction of the applied force. These two forces are equal but acting in the opposite direction. So equal in magnitude but in direction, both are acting in the opposite. So these two equal and opposite forces constitute a couple. This couple makes the body to turn. This turning effect of couple is called as moment of couple. Turning effect is called as moment. The turning effect of couple is called as moment of couple. Okay. Now, I am going to hold the scale at this point. Let us consider this as the axis of this rotating body. This body is going to rotate. For example, I am holding the body, the scale at its axis of rotation. Now I am going to apply a force at this point. So this is the point where I apply the force. So this is the point of application of force. So when I apply a force, this force makes the body to rotate or turn. So the turning effect of force. This turning effect of force is called as moment of force. So which has the formula, the force into the distance between, the perpendicular distance between the axis of rotation and the point of application of the force. So the moment of force, which is also called as rotational force, which is also called as torque, is nothing but the force applied into the perpendicular distance between the axis of rotation and the point of application of force. That is the distance d, F into t, right? Now, I am going to hold the scale like this. So now, I am going to hold, right? Now, if I rotate the body like this, so this hole is the axis of rotation of this body. Now, when I rotate, there is a mass due to rotation. There is a mass due to rotation. When I hold the scale here at this point and then rotate, now there will be some mass due to rotation. So when I hold the scale at this point at the edge and then rotate, it is difficult for me to rotate because the mass due to rotation is heavier. But when I rotate, by holding the scale at this point, I can easily rotate because the mass due to rotation is very lesser when compared to the mass due to rotation at this point. So the mass due to rotation is also called as rotational mass. The rotational mass is also called as moment of inertia. Moment of inertia. So moment, the turning effect. Inertia, that is, it's directly proportional to mass. So when I rotate a body, the mass due to rotation is called as rotational mass or moment of inertia. So, to know more about the moment of inertia, we must know the formula I is equal to mr square. M is the mass of this body, r is the radius of gyration. So radius of gyration means, for example, if I hold the scale at this point and this is the axis of rotation, and the midpoint of the scale is called as the center of gravity of the object or the scale, then radius of gyration is nothing but the perpendicular distance between the axis of rotation and the center of gravity of a body. So it is a perpendicular distance between the axis of rotation and the center of gravity of a body. So when you hold here, for example, the distance between the CG and the axis of rotation is 15 centimeter. So mr squared, mass of this scale into 15 centimeter square, right? So now moment of inertia will be more. When I hold here, between the center of gravity and this point, the distance will be very less. So m into r squared. So the moment of inertia will be less. So the mass due to rotation is less here. Thank you. I think you must have understood.